Welcome back. This is Mr. Hassan's Maths channel. I'm now going to be answering question number 14 from the June 2017 Core Mathematics C3 paper from the International A-Level of Edexcel. And this relates to their new syllabus of P4, this particular question, this question is about parametric equations. So it says figure 6 shows a sketch of the curve C with parametric equations. X equals 8 cosine cubed theta, y equals sine squared theta, and theta is between 0 and pi over 2. Okay, so the value of theta is between 0 and pi over 2. Now it says, given that the point P lies on the curve C, so the point P lies on the curve C, and has parameter theta equals pi over 3. So the parameter for P is theta equals pi over 3. So at P, theta equals pi over 3. All right, so we have to find the coordinates of the point P. Okay, so we need to find the coordinates of the point P. So P has coordinates xy, xp and yp. Now we know at P, theta is equal to pi over 3. So we can say the x coordinate of P is going to be given by, when you replace theta here with pi over 3. So you have 8 times cosine cubed theta, 8 times cosine cubed of pi over 3, which is the same as saying 8 times the cosine of pi over 3, and that cosine pi over 3 is cubed. Remember, cosine cubed of theta is the same thing as cosine theta all cubed. That's actually what it means. It's just written in this form. Okay, now pi over 3, that's like 60 degrees, that's half. So 8 times a half cubed, which is 8 times 1 over 8, which gives you 1. So the x coordinate of P is 1. So we can say that P, the x coordinate is going to be 1. And the y coordinate of P is going to be given by replacing theta in here with pi over 3. So you have 6 times, and this time is going to be the sine of pi over 3, but this time squared. So that's 6 times. Now the sine of pi over 3, the sine of 60 is root 3 over 2. That's going to be root 3 over 2 squared, which is 6 times 3 over 4. So 6 times 3 over 4, which gives you, that's going to be 3 over 2. That's 9 over 2. 9 over 2, which is the same as 4.5. So we can write that as 4.5. So those are the coordinates of the point P. That's part A done. Okay, so yeah, that's fine. Then it says the line L is a normal to C at the point P. So the line L is a normal to the curve C at the point P. Now, the normal to a curve. At P, there is a tangent to the curve, which shares the same gradient as P. Okay, so at the point P, you have this line, which is the tangent. This is the tangent to the curve at the point P. And what's special about that is that it shares the same gradient as the curve at that point. Now, the normal to a curve is perpendicular to its tangent. Okay, so this is the tangent, and this is the normal. All right, so the normal, its gradient is perpendicular to that of the tangent. So if we can find the gradient of the curve at the point P, then the normal will have a gradient which is a negative reciprocal of that. And if we know that, we can then find the equation of the normal. Okay, so what we need to do first is we need to find what dy dx is. Okay, so we need to find dy dx. All right, now, what we notice here is dy dx. Okay, let me just make some space, put this up there for now. Okay, dy dx because we have the curve defined parametrically in terms of a parameter theta, we can say it's the same as dy d theta times d theta dx using the chain rule. That's the same as dy dx. Now we know that y equals 8 times cosine or sine theta squared. Sorry, 6 times. Okay, 6 times sine theta squared. So again, I'm going to write it in this form because it makes it easy for me to differentiate. That's y. Okay, so if I want to find dy d theta, then I multiply by the power, so I get 12. And this stays as it is. This stays as sine theta. I take 1 from the power, but then I multiply by the differential of what's inside the function. This is from the chain rule. And the differential of sine theta is cosine theta. So this becomes cosine theta. Okay. So this will give us 12 sine theta cosine theta. Okay, that's dy d theta. Now we got to find what dx d theta is. So then we can find d theta dx, which will be its reciprocal. So x equals 8 cosine cubed theta, which is 8 times cosine theta all cubed. As we know, x equals 8 cosine cubed theta. That's right, just to make sure. So we can find dx d theta in a very similar way. We multiply by the power, so it gives you 3 times 8, 24. We take 1 from the power, so you have cosine theta to the power of 2. And then we multiply by the differential of what's inside the function, which is going to be minus sine theta this time. If you differentiate cosine theta, you get minus sine theta. So this will give us minus 24 cosine squared theta times sine theta. That's dx d theta. So we can say that dy dx, therefore, is going to be equal to dy d theta, which is this, 12 sine theta cosine theta, times d theta dx, which is 1 over all of this. So I can just put it straight away underneath there. It's going to be minus 24 cosine squared theta times sine theta. Okay, so there's what we got so far. Now we can see the sine theta cancels with the sine theta, and one of the cosine thetas cancels out, and the 12 cancels with the minus 24. So you're left with basically 1 over negative 2 cosine theta. Okay, so now we've got to find the gradient when theta is at p. Theta equals pi over 3. Okay, at p. So we've got to find the gradient at p. That will be the gradient of the tangent. So at p, dy dx is going to be minus 1 over 2 times the cosine of pi over 3. Okay, which is equal to minus 1 over 2 times, now the cosine of 60 is a half, so minus 1 over 2 times a half, which is negative 1. So we can say the gradient of the tangent at p is equal to negative 1. So therefore, the gradient of the normal at p is equal to 1. Okay, the gradient of the normal is a negative reciprocal. So we can say that the gradient of the normal is equal to 1. The point P has coordinates, as we found earlier, 1 and 4.5. So we can now, 1 and 4.5, we can now find out the gradient of the normal y minus, the equation of the normal y minus y1 equals m times x minus x1. So you have y minus 4.5 equals 1 times x minus 1. So you have y minus 4.5 equals x minus 1. Add 4.5 to both sides, so y equals x plus 3.5. Minus 1 plus 4.5 is 3.5. And I think that's exactly what we had to show. Y equals x plus 3.5. Good. So there's the answer to part B of this question. And next is part C. The finite region S shown shaded in figure 6 is bounded by the curve C. Okay. That line should come later. 1 second. Okay, it's bounded by the curve C, the line L, the y-axis, and the x-axis. So this is the region S. We've got to show that the area of S is given by this expression here. So 4 plus 144 times the integral of all of this with respect to theta between 0 and pi over 3. Okay, so that looks a bit daunting there, but we're going to try and tackle it. Now, so I'm guessing that the 4 must be the area of the section which is like this trapezium area. So I'm going to split this into two sections. Okay, I'm going to split this so that I have a trapezium which I can find the area of, and I know, for example, that this point is 3.5. I know this point is 1. Okay, because we know that the coordinates of P are 1 and 4.5. And we know that this line passes through the y-axis at 3.5. That's the y-intercept. C equals 3.5. That's how I know that 3.5. And I also know that this point here is 4.5, as I just mentioned, because those are the coordinates of P, 1 and 4.5. So I know that this is like a trapezium. Okay, it's like a trapezium, this first part. Let's call this section 1 and section 2. So section 1 is like a trapezium. This is one of the parallel sides, which is 3.5. This is the other, which is 4.5. And this is the distance between the parallel sides, which is 1. So the area of that trapezium is going to be the distance between the parallel sides divided by 2 times the sum of the parallel sides. Okay, so you end up with that's going to be 8 divided by 2, which is 4. So that's where this 4 comes from. So you have 4. So that's part of it. That's the area of section 1. Okay. The area of that first part here. Now we're looking for the area of this other part over here. Okay, so we need to know this information here, okay, in order for us to find that. So we need to find the area under the curve, okay, between these 2 points, 1 and this point over here in terms of x, which we can find. So it's going to be, let's call this x1 and x2 for now. Right? We don't really need to know what they're in terms of x. We have to change them in terms of theta in the end. So you got the integral of y with respect to x. That's what we're trying to find between these limits. That's what we need to find in order to find the area of this section here, the area under this curve between these 2 points. Now, because we have a third parameter theta here, we're going to write this in another way in terms of theta. So this is the same as saying y dx d theta d theta. It's like those cancel out to give you y dx. So in this case, we have to write everything in terms of theta. So this is going to be theta 1, this is going to be theta 2, and y and dx d theta must be given in terms of theta. So y is already in terms of theta, so I can replace that with 6 sine squared theta. But now I have to have dx d theta. And we kind of already worked that out, I think, in the other part. I'll just do it again. This is 3 times 8, which is 24. And this is cosine theta squared times minus sine theta. Okay, so dx d theta is going to be negative 24 cosine squared theta times sine theta. That's dx d theta. All right, so now we can replace everything that we need. I'll also find what the theta 1 and theta 2 are before we continue. So we know that at this point here, at P, the x coordinate is 1. And at P, at this point P here, okay, we know that theta is equal to pi over 3. Okay, so that's going to be theta 1. Theta 1 is equal to pi over 3. And we need to find what theta 2 is. Okay, theta 2 is at that part here. That's when y equals 0. Theta 2, this is part. This is going to be, we want to find this in terms of theta. This is x2. We want to find it what's in terms of theta. So this is when y is equal to 0. Okay, so y equals 0. All right, so we're going to say that 6 sine squared theta equals 0. So we'll end up with sine theta equals 0. Because divide by 6 and then take the square root, that's going to be 0. So theta is equal to 0 degrees because our values are only between 0 and pi over 2. That's the only place where theta is equal to 0. Is going to be at 0 degrees. So this is going to be, 0 radians, not degrees. 0 radians. So this theta 2 is going to be equal to 0. So now we can say we've got theta 1 as pi over 3, theta 2 as 0. We have y as 6 sine squared theta times dx d theta, which is minus 24 cosine squared theta times sine theta, and this has to be integrated with respect to theta. All right, so now we've got something that looks not quite the same as this. There's going to be some changes we're going to have to make. Now, we have here cosine to the power 4 theta, cosine squared theta. Okay, what I'm thinking we need to do here is change this. First of all, let's take out the constants. We have 6 times 24. That's going to be 120 plus 24. That's minus 144. So I'll take out minus 144. This is pi over 3 and 0. So I'm now got sine squared theta times cosine squared theta times sine theta d theta. All right, now, if I have to end up with cosine to the power 4 theta. So how is that going to happen? Well, if I rewrite this as 1 minus cosine squared theta, then I will end up with something in that form, I can see. And the other thing I notice is that these limits here are pi over 3 on top and 0 underneath, and this 144 is positive. So what I'm thinking I'm going to do now is I'm going to swap these limits, which causes this sign to change, okay? Because it will give you the opposite sign if you do 0 into all of this minus pi over 3, or if you do pi over 3 into all of this after you've integrated it, into all of that after integrated minus 0. It'll give you the opposite sign. So if you swap these limits around, you can change the sign of this. That's one of the things we can do. So this is 144, and this is going to be pi over 3, and this is going to be 0. I'm going to change the sine squared theta into 1 minus cosine squared theta, and then I've got here times cosine squared theta, sine theta. And I've got my d theta. So now, if I expand this bracket, I have 144 pi over 3 and 0. I have 1 times this expression, which is going to be cosine squared theta times sine theta. And then I've got minus cosine squared theta times this expression, which is minus cosine to the power of 4 theta times sine theta with respect to theta. And I think that's exactly what we had to show. Yep, it's the same thing, except just written with the sine theta first, that's all. So I'll just rewrite it so it's the same. So therefore, I can say that's the area of section 1 or 2. Okay, so therefore, the area of S is going to be 4 plus 144 times the integral of, I was about to write the square root, 4 plus 144 times the integral of, between the limits of pi over 3 and 0, of sine theta times cosine squared theta minus sine theta times cosine to the power 4 theta with respect to theta. So that's quite a long process, 6 marks, and we ended up with the answer in the end using parametric integration. Okay, so that's the answer to part C, and of course I guess part D will say find that area. Hence, by integration, find the exact area of S. So we have got to find the whole of this answer for this integral. All right, so you've got to integrate all of this. Now, what I notice here is you have sine theta times cosine theta, and that's like squared. And you have sine theta times cosine theta, and that's raised to the power 5. So it's like something where you have f of x times g, f dash of x, sorry, times g f of x. Okay, so inside this function is cosine theta. This main function is something squared. Here, this main function is something to the power 5. The differential of what's inside the function is, the differential of cosine theta is minus sine theta. So that's of the right form. So of the correct form might be the different sign, but it's the correct form for the differential of what's inside the function. So we can use the reverse of the chain rule here. We can use the reverse of the chain rule here to integrate both of these. Okay, they both have that same concept. So we can say the area of S is going to be 4 plus 144 times. Now we can integrate this. So this is going to be, if I do it in the way I like to do it, cosine theta, and there will be cosine theta to the power of 3. You add 1 to the power, divide by the new power, and also you divide by the differential of what's inside this function, which is minus sine theta. Okay, and I've got minus, and then I've got sine theta And then I'm going to raise this cosine theta to the power 4 to add 1 to its power, divide by the new power, and then the differential of what's inside the function, which is minus sine theta. And you're going to have your limits of pi over 3 and 0. So we have 4 plus 144 times. So what happens here? The sine theta cancels here and there. So we're left with, that's a minus 1 over 3 cosine theta cubed. I'll leave it like this so that it's easy to substitute. And there will be minus, and a minus gives you a plus. And that will be 1 over 5 sine theta raised to the power of 5. And we have our limits pi over 3 and 0. So now we can substitute those limits in. So we have 4 plus 144 times. This is minus 1 over 3 times the cosine of pi over 3. And that has to be cubed. Plus 1 over 5 times. Sorry, that's supposed to be cosine. What am I doing? I don't know why I wrote sine there. It's supposed to be cosine. Some of you might have spotted that mistake before and already written something down in the comments, but be careful about that. That's going to be the cosine of pi over 3 to the power of 5. Okay. 1 second. I've got to make sure that there's nothing else as well. So I'm going to take away. I have minus 1/3 times the cosine of 0 cubed plus 1 over 5 times the cosine of 0 to the power of 5. Okay, so that's, you have to take away all of that as well, right? Because you put 0 into those as well. So now we have 4 plus 144 times. Now the cosine of pi over 3 is half. 60 degrees, right? A half. A half cubed is 1 over 8. So it's minus 1 over 3 times 1 over 8 plus 1 over 5 times. So you got 1 over 2 to the power of 5, which is 1 over 32. Okay, minus, and you have here minus 1/3. Now the cosine of 0 is 1. So that's minus 1/3. Plus, and you're going to have the cosine of 0 again is 1. So it's 1/5 times 1. So that's 1/5. Okay, so we're almost there. I could stick this in my calculator if I wanted to be lazy. I'm going to just work it out. You can put in your calculator at this stage. There's no problem. That's minus 1 over 24 plus 1 over, that's 150, 160. Minus, and you got, that's going to give you, let's just add these together. That's going to be 15. That's minus 3 over 15 plus, and that's going to be, in fact, that's minus 5 over 15 multiplied by 5. And that's going to be 3 over 15. Okay, so now we have 4 plus 144 times. Okay, now we have to add these together. So I'll just use a calculator for this now. So you have 1 over 160, 1 over 160, minus 1 over 24. That gives you minus 17 over 480. Okay, minus, and this is going to give you minus 5 over 3 plus 3 over, so minus 5 over 15 plus, that's minus 2 over 15. So it's going to be minus, so it's plus 2 over 15. So let's work out what this is. So you have that plus 2 over 15. That gives you 47 over 480 times 144. 141 over 10 plus 4, 181 over 10. So when you work it out, you get 181 over 10, which is 18.1 square units. So there's the answer to this question. It's quite a long one, okay, but we got there in the end, and that is the correct answer. You're going to be very careful about these questions, not making silly mistakes. But that completes the whole of this question, question number 14, from the C34 paper from June 2017, Other questions from this particular paper can be found in the playlist, which will appear in this section over here. Other questions from this topic of parametric equations, you'll find them in the playlist in this region over here. And you can subscribe to my channel by clicking on this link, and the video that appears in this region up here will help you to find or navigate my channel to find what you need efficiently. Thank you for watching, and see you soon.